It's hard to believe, but right now, beneath the landscapes we know so well, a silent crisis is brewing. From the icy peaks of Alaska to the forested coasts of California, the ground is humming.
Travellers are on alert today after a volcano erupted on the Indonesian island of Java, spewing gas and ash more than 2 kilometres into the sky.
For generations, these volcanoes have loomed in the background, their craters blunted by time, their slopes softened by forests and snow. Most were thought dormant, some were barely studied at all. Yet this year, something has shifted. Scientists initially dismissed anomalies in their data, an odd sensor flicker, a thermal signal shrugged off as weather. But as weeks passed, the signals kept coming, accumulating like storm clouds on the horizon. Satellite arrays circling the globe recorded an unmistakable pattern, a swelling tide of heated rock, shifting earth and rising seismic static along the western edge of North America. In successive bulletins, leading geologists offered an urgent, sobering message. The findings are staggering. By 2025, 63 volcanoes had erupted, 21 of them for the first time in many years, breaking long-standing periods of calm. And now, in a wave of breaking alerts, scientists warn many more are primed to erupt with little to no warning, due to a newly understood phenomenon, stealth volcanism. These are not the dramatic, rumbling giants whose warning signs shake cities for weeks. These are the so-called silent ones, driven by warm rock, hidden magma chambers, and magma flows so slow they mask all hints of unrest. And they are everywhere, under forests, beneath towns, and even far out at sea. With tectonic stress at a significant high, concern is mounting as experts race to decode which peak could blow next, and which communities might find themselves with almost no time to react. The question haunting scientists is the same. Are we on the verge of an eruption wave so quiet, so deceptive, it could change everything we thought we knew about living on this restless planet? Chapter 1. The Stealth Awakening: How Silent Volcanoes Evade Detection. Imagine a volcano so quiet, so restrained, it conceals its unrest until moments before disaster. This is not fantasy, but science. Recent years have revealed a new breed of eruption, confounding the world's experts and challenging the principles of volcanic risk analysis. It started with a closer look at Alaska's Veniaminof. For years, its snowy crater appeared tranquil. In 2025, satellites first detected faint tremors in its vicinity. When ground teams scoured the area, no classic signals, such as significant ground swelling, strong sulfur odors, or persistent tremors, were recorded. Instead, the signs were subtle: warmth in deep rock and minor seismic shifts through microcracks. The magma, instead of surging upward in bursts, moved like syrup, threading through narrow fractures and pooling in small, concealed chambers. It became clear to scientists: slow flows and compact magma pockets can obscure all evidence of building pressure. The mountain's icy cap contained the heat below, generating a hidden boil that even sensitive thermal satellites couldn't fully distinguish. But Veniaminof wasn't alone. Reviewing data from volcanoes as dispersed as Mount Shasta in California and undersea peaks off Oregon's coast, a pattern emerged. Each volcano had unique signals, but all concealed their unrest with the same ghostly skill. The magma was moving, but the earth kept it secret. These stealth volcanoes do something unsettling. They skip the warning phase. No precursor earthquakes, no obvious gas vents, no mass movement of animals. Instead, they slumber in apparent stillness, then awaken swiftly, sending ash, gas, and lava skyward with little or no traditional warning. Why are these eruptions so difficult to predict? Warm rock can soften seismic waves, muting the shakes typical of volcanic activity. Small chambers trap gases that would normally escape in advance. Slow magma creep can mimic harmless tectonic movements. The templates scientists have relied on for decades are being upended. What happens when the ground refuses to betray its next move, when the only hint of disaster is silence?
Chapter 2. Veniaminof, Alaska's Icy Deceiver.
Rising in the wilds of southwestern Alaska, Veniaminof is a frozen colossus crowned by snowy fields and encircled by glaciers. Its broad caldera has withstood centuries of storms, but in 2025, it managed the ultimate deception. Once considered reliably monitored, active yet under control, it had erupted before with visible plumes and warning tremors. This time though, the volcano turned hiding into an art. Thermal satellites first picked up faint heat signatures in late spring. Nothing dramatic, just a patch of warmth inside the ice. Drones detected occasional puffs of steam, quick to vanish. Teams camped along its slopes, waiting for a shake or a sulfurous spike. But significant warning signs never came. The true unrest was far below. Magma moving so sluggishly, it nudged chamber walls for months, displacing rock by centimeters. This slow build-up distorted sensor readings, making unrest look like background noise. Then, on a windless October night, everything changed. In less than 2 hours, the caldera split, unleashing a fountain of ash and fire that darkened the skies above and plunged the surrounding wilderness into chaos. There was no build-up, no mass evacuation, just silence, then eruption. Later seismic records showed the volcano gave barely 20 minutes of precursor tremors, muffled and brief. One volcanologist called it the ultimate stealth eruption. Why did Veniaminof fail to warn? Warm, ductile rock absorbed minor seismic signals. Its small, isolated magma chamber prevented major gas plumes. Even the snow quieted surface heat and noise. Everything about this eruption defied traditional forecasting. But Veniaminof sounded an alarm. If one of the most closely watched volcanoes on Earth can erupt without warning, how many more might be waiting in silence? Chapter 3. The chain reaction, 21 new eruptions in 2025. For years, attention focused on the most dramatic volcanoes, Etna, Kilauea, St. Helens. But in 2025, the narrative changed. Scientists confirmed 63 eruptions from 58 volcanoes, with 21 cases from those considered dormant or long quiet. It started as a statistical curiosity, 1 or 2 overlooked peaks erupting, dismissed as isolated events. But as the months passed, a pulse swept through the ring of fire that demanded attention. Lesser watched volcanoes in Alaska sent up surprise plumes. Underwater peaks off the Pacific Northwest released steam and gas. In the forests of Northern California, an ancient cone dusted treetops with ash. Each event showed the same pattern. There weren't weeks of tremors or waves of sulfur. Sometimes the only sign was a sudden satellite heat signature, or a fishing vessel reporting odd bubbles and discoloration above an undersea volcano. Most eruptions were brief, with impacts localized, but these incidents revealed a deeper truth. The silent mechanics of small magma chambers and slow flows now affect volcanic risk on a broader scale. Analysts sifted through global data, thermal plumes, shifting ground, microquakes absorbed by layers of soft rock. Even established forecasting models struggled to keep up with the unpredictable pattern. From Tokyo to Seattle, a new watch list formed. 21 volcanoes capable of erupting without warning, spread from Alaska to California, from remote islands to near city borders. Some had already awakened, others showed faint pulses deep in the earth, noticed by instruments, understood by only a few. If these volcanoes erupt in close succession, could it trigger disasters? Ash on cities, lahars in rivers, skies shadowed by dust? Or is this the planet's call to remember that beneath our feet, silence is never safety? Chapter 4. The Undersea Threat. Shadows below the Pacific. On land, volcanoes are visible, their outlines familiar, but the biggest wildcard is not on land. It's hundreds of feet below the ocean's surface, far from routine human observation. This year, satellites noticed a new anomaly. An undersea peak off Oregon's coast, deemed long extinct, was warming. Scientists analyzed changes in water chemistry, dissolved gases spiking, discolored plumes appearing. Local fishers reported bubbles at sea, the ocean foaming oddly. This undersea volcano, part of a chain stretching from the Aleutians south, became a case study in eruption forecasting. In early summer, experts warned conditions suggest eruption likely sometime in 2025. This was remarkable. Forecasting eruptions more than hours ahead is rare, as Earth's processes are chaotic and subtle. Why the concern? An undersea eruption could, in theory, trigger tsunamis, deposit ash and steam on coasts, disrupt temperatures, affect fisheries, and threaten marine life with volcanic gases. Most critically, undersea eruptions often leave few surface warnings. By the time satellites or ships notice the heat, the eruption could be in progress. Science can't say exactly how many undersea volcanoes could awaken next. The Pacific floor holds countless hidden volcanoes, the majority unmapped in detail, and tectonic stress can bring surprises. Chapter 5. A world on edge. The global geological alert. Something terrifying is happening beneath our feet, and for the first time in decades, the world's top geological agencies are quietly aligning behind one unsettling conclusion. This is not regional, it's global. What began as isolated warnings from Alaska, the Andes, and southern Europe has escalated into what experts now call a planet-wide tectonic pulse, a correlated chain of stress signals that almost no one saw coming. It all converged on October 21st, 2025, a date that is already being whispered about in scientific circles. On that day, analysts reviewing cross-continental satellite data noticed something chilling. Subtle but synchronous crustal movements across multiple volcanic belts, stretching from the Pacific Ring of Fire to Italy's Apennines and into the deep fault networks beneath North Africa. These weren't random blips, they formed a repeating pattern, an unmistakable signature of rising tectonic strain, and the volcanoes are responding. From Alaska's Veniaminof to the restless cone of Mount Cleveland, from Pavlov's fuming ridge to Shasta and Lassen further south, one message is emerging like a pulse through the crust. Something is stirring. Even the mighty Cascadia subduction zone, normally one of Earth's quiet giants, has begun releasing faint gas bursts and localized heat patches, signs that magma pathways might be reorganizing deep below. But the most alarming development? The rise of what scientists now call stealth volcanoes, systems capable of erupting with almost no warning. Their magma chambers are smaller, quieter, and buried beneath layers of warm rock that hide the telltale seismic signatures. Old forecasting models assumed days or weeks of precursors. That assumption is now collapsing. These systems could go from quiet to erupting in hours. Across the globe, sensor networks are on red alert. Satellites sweep volcanic arcs every few minutes. Geophysicists barely sleep, knowing the Earth might offer only a handful of cryptic signs before its next explosive chapter begins. The question haunting everyone: is this global pulse the beginning of a new volcanic era, or the final warning before multiple systems ignite at once? Chapter 6. When the warning signs disappear. There is a terrifying new reality emerging in 2025, one that scientists hoped they would never have to confront. For generations, humanity believed it could rely on the planet to warn us before disaster. Volcanoes were supposed to signal their intentions: tremors, swelling ground, rising gases, harmonic quakes. But what happens when the Earth stops sending warnings altogether? This is the chilling hallmark of stealth volcanism, a phenomenon that is dismantling everything we thought we knew. The events of 2025 proved it beyond doubt. In the Eruptions, sensors showed flatline gas emissions, zero activity, right up until the ground ripped open and ash blasted into the sky without a single precursor. At Lassen, only tiny crack shifts appeared, barely millimeters, before a nighttime fissure erupted with pumice and steam like a volcanic ambush. Scientists now understand the horrifying mechanism: small, shallow magma pockets hiding beneath warm, ductile rock. Instead of fracturing the crust and announcing unrest, the Earth bends. Instead of releasing warning gases, the chamber seals itself like a pressure cooker. Instead of hundreds of quakes, it whispers with micro-tremors too faint for most algorithms to detect. Old forecasting models crumble under this new threat. The question haunting emergency planners is simple and devastating. What do you do when eruption time drops from days to minutes, when your only alert is the eruption itself? One volcanologist summarized the nightmare perfectly. We're now searching for disasters that refuse to reveal themselves. Chapter 7. The human cost, cities and communities at the brink. This isn't just a scientific crisis, it's a human one unfolding in real time. Millions of people live in the shadows of volcanoes that may no longer give them a fighting chance. In Alaska, entire villages depend on precise forecasts. With stealth eruptions, warnings may come too late to reach remote communities. Along the coasts and rivers, evacuation windows shrink to minutes, not hours. In California, regions around Shasta and Lassen welcome thousands of tourists each week. Any sudden eruption could trap hikers, campers, and families with no escape route. Offshore volcanoes pose a greater danger still. A silent undersea blast could unleash a tsunami before sirens even activate. Ports could shut down instantly. Global shipping lanes, lifelines for food, fuel, and medicine could be paralyzed without warning. Even major metropolitan areas are no longer untouchable. Portland, San Francisco, Vancouver all sit within ashfall range of volcanoes that may erupt quietly and instantly. Their power grids, water treatment plants, and flight corridors rely on monitoring networks that were never designed for eruptions without precursors. Geologists now fear hundreds of so-called dormant systems may simply be biding their time. The predictability that modern societies depended on is slipping away. If this stealth era continues, one question looms over every city, every coast, every valley. When the next eruption comes without warning, who will have enough time to survive and who won't? Chapter 8. The science chase, racing against time. In research labs and monitoring stations, urgency dominates. Every tremor, every satellite blip could have real-world consequences. Scientists are racing to deploy new sensors. Magnetometers are calibrated to trace minute changes, signals of sliding magma deep within the Earth. Acoustic arrays listen for subsonic rumbles ignored by past models. Satellites scan for even slight temperature shifts on volcano slopes. International collaborations are at an all-time high. Data moves across borders, Russia to Japan, Canada to Chile. Scientists ask if a true fingerprint of stealth eruptions can be found, discrete signals that precede such events, offering even a brief warning window. Some clues are promising. Fluctuations in the Earth's magnetic field, micro-anomalies in atmospheric composition, tiny deformations in the ground. But every new detection brings new challenges. Some stealth volcanoes offer no advanced signal at all. Each case seems to rewrite the script. Public pressure is growing. People look to scientists for certainty, but at press conferences, volcanologists urge caution. This may be the new norm. We must respect the Earth's unpredictability. Is this a race science can win? Or have we entered a new era where silence defeats even our most advanced monitoring?
Chapter 9. The pulse beneath our feet.
As the world faces an uncertain volcanic future, one truth remains: the ground is never truly at rest. It is always alive, shifting and changing in ways both familiar and unknown. The 21 new eruptions in 2025 are not just statistics, they're a wake-up call that Earth's rhythms can defy even our best science. From Alaska's ice-locked Veniaminof to the hidden undersea peaks of the Pacific, these events hint at deeper mysteries below our feet. Land and sea, city and forest, all ride on the same fragile crust. Traditional warning signs, rumblings, gas, heat, are giving way to subtler, quieter portents. Our planet is changing, sometimes faster than what our models or our courage can match. No region is immune, no city is guaranteed peace. The scientific warning is clear and unsettling. Watch the ground and don't mistake silence for security. As alerts accumulate and as 21 volcanoes and more gather strength, one urgent question remains. Are we paying close enough attention to the quiet, to the silence that precedes the storm, to survive this era of stealthy volcanic unrest? If you want to stay even a single step ahead in this new volcanic era, subscribe and turn on notifications. Because as the ground beneath us shows, the quietest moments sometimes hold the biggest warnings. And our story with the restless Earth isn't over yet.